Good morning, everyone. My name is Supawit Omsin, and I'm here with my teammate Rachata Theerapraphotphanu. Today, I'm excited to present our project, the Smart Home Project, which we developed as part of the CSS332 microcontroller and application course. This project gave us a chance to explore how microcontrollers can be used to solve real-world problems. And now, I will hand it over to Rachata, who will share the motivation behind our project and explain its core concept.
Motivation and core concept. Let's start with the motivation behind the project. Most of us have probably experienced one or more of these pain points at home, such as manually turning device on and off, leaving home only to realize we leave the light or fan running, inconsistent habits that end up with wasting electricity. After identifying this challenge, we start thinking about smart solutions, and that become our core concept, which include using automation to make life easy, design energy aware system to reduce unnecessary consumption, building a structure that both modular and scalable so we can extend it easy in the future. And finally, we enabling eco-conscious living the smart decision made by the system. In the circuit, here is all the circuit. This is the backbone of the system, how all the components talk to each other. We use an Arduino board to coordinate sensor input and output action. Some components you will see here include ultrasonic sensor for distance detection, keypad for user interaction, soil moisture sensor for measure moisture, buzzer for the alert system, two servo for the door and garage door. The challenge here was wearing everything efficiently will keep the design clean and safe.
In this part, I would like to begin by walking you through our source code. First, here are the main libraries we used in this project, which are keypad for reading input from the keypad, servo for controlling the servo motors, wire for I2C communication, liquid crystal I2C for displaying messages on the LCD screen. After importing the libraries, we initialize the global variables. These include variables for tracking the system status, like access control, as well as objects for the LCD, keypad, servos, and other hardware components. Next is the setup function. This is where we configure and initialize all components that only need to be set up once. For example, we call serial begin for serial communication, attach the door servo to pin A2, or set the buzzer pin as an output. Moving on the loop function. This is where the main logic runs continuously. It handles sensor input, updated outputs, and responds to user interactions. We have organized the logic inside the loop into four main parts, which are mode selection, digital door lock, garage door control, and watering alert system. And now, I will explain the third part for an instance. In the garage door control section, we used an ultrasonic sensor to detect nearby movement. If a car approaches within a certain distance, the garage door opens automatically. Overall, we have structured the code into clear modular sections to make it easy to maintain or expand each part of their smart home system in the future.
Feature and purpose. Beyond the technical side, this project had a bigger purpose to take what we have learned and apply it to the real world and ultimately make daily life easy, use energy more intelligently, and demonstrate how even a basic microcontroller can lead to smart impact solution. Here are the key features we implement. Digital door lock secure access to the house. Automatic door opening. The door open automatically when the house unlocked, make it very convenient for the user. Garage door with ultrasonic sensor. You just drive your car up to it and it opens. No need to pass anything. Plant water alert. We want something simple to remind us to care for plants. When soil moisture is low, the system alert the user. Each feature was chosen because it's simple, practical, and improve daily life. We built the project over a span of 2 months, from April to March 2025. Here what we use Arduino IDE as our development platform. Using the C++ language, a range of sensor and input component is what tight timeline, but it helps us focus and iterate quickly.
This project was made possible through the collaboration of our team members. Each of us took on key roles ranging from coding and circuit design to documentation and testing. And we would like to express our sincere gratitude to Ajahn Nathakit and Ajahn Supachok, our project advisors, for their guidance throughout the project. We used several tools in this project like Arduino hardware from Arduino and sensors to the Arduino IDE for software development. Some simulations were also done using platforms like Tinkercad for early prototyping. And we would like also to acknowledge the role of ChatGPT, which assists us with coding logic and troubleshooting explanations. Lastly, in terms of references, we refer to official Arduino documentation, community guides, datasheets, and ChatGPT to solve technical challenges and clarifying concepts. Our project was truly a collaborative effort, with each of us taking on specific roles while also contributing together during planning. Rachata Theerapraphotphanu focused heavily on the technical side, developing the core code for the garage door, digital lock system, and LCD display. He also tested the hardware, assembled the circuit, and physically integrated everything into the house model. Supawit Omsin contributed to both planning and creative aspect, coded the plant watering alert system, built the physical house model, and designed the presentation slides you are seeing today. We both participating in brainstorming and refining their initial concept and worked closely to ensure all components came together smoothly.
In the conclusion, that brings us to the end of our presentation. Thank you so much for your attention. We hope this smart home project gives you a look at how microcontroller can power real change in everyday life.